Was that too loud? That seemed loud. My name is Luke Ossink. I'm here to introduce the presenter today. We have Jennifer Schmidt from Herrera. She's going to give a talk called Mapping, Where You're Headed and How to Get There. She told me, this is a quote, she's as excited as you can possibly be about GIS stormwater mapping. So it's going to be a pretty good presentation. It's going to be 20 minutes, and then we'll have 10 minutes for questions and answers at the end. It will be recorded, but not the question and answer session. So if you're going to say anything embarrassing, save it for that portion. And make sure that your cell phones are turned off. So help me welcome Jennifer.
Hi, good morning. If I move too far away from the mic, let me know. I'm kind of naturally soft-spoken, so I just want to make sure everyone can hear me. So as Luke said, my name is Jennifer Schmidt. I'm with Herrera Environmental Consultants. I manage the spatial and data science group, and I do a lot of work with municipalities on helping to meet the NPDES mapping requirements. So quick overview of the presentation. I'm going to briefly go over the permit requirements. I will say that I'm not a permit expert. I'm coming at this from the perspective of a GIS specialist, so I'm looking at it where kind of the rubber meets the road. So I'll do my best to answer detailed permit questions if they come up, and otherwise I'll put my colleague Rebecca Dugopolsky on the spot for that. Then after I introduce the permit requirements, I'm going to go through each one of them briefly and show a specific case study. Then because I want this to be a practical session where you can come away from this with some tools that you can implement for your jurisdiction. I'm going to go over some mapping tools and resources. And then briefly, I want to talk about, once you do all of this mapping, how do you put it to work? And then finally, I want to just briefly touch on what's new for the mapping requirements in the new permit. So what this slide is showing is, there's this requirement of mapping of the MS4 on an ongoing basis, but there are a lot of different things that fit under that general umbrella. So this slide is showing the mapping requirements for Phase 2 Western Washington municipalities. One of the primary differences for Phase 1 is that this requirement in the top right corner for tributary conveyance mapping is 8 inches for Phase 1, not 24 inches. And the purpose of this slide is just to show there's a lot going on, and it can be difficult to kind of decipher what each of these really mean when you get into the mapping environment. So I'm going to walk through each of these. I've got a little diagram here that kind of, it's a little cartoon of a system, and it highlights the portion of the system that I'm talking about. So first, I want to go over the requirement of this known MS4 outfall and discharge point mapping. I'm going to talk about this in two parts. So first, I'm going to talk about outfalls and then discharge points, although there is quite a lot of overlap. One of the primary mapping considerations, we've worked on many projects where we've had to determine what is an outfall point and what is a discharge point. That can be a little bit more complicated when you actually sit down to map than it seems. I wrote down the language from the permit. So for the purposes of this talk, outfalls are points where a discharge leaves the permittee's MS4 and enters surface water. And then discharge points are locations where a discharge leaves the MS4 through facilities or BMPs designed to infiltrate. So practically speaking, it's where your stormwater system terminates. One of the challenges with mapping outfalls and discharge points is that a lot of times, if you don't have this mapping already and you have a large geographic area, it can be difficult to know where to start. So one approach that we've used in the past is to look at focusing on the intersection of your stream or your receiving water data and your stormwater infrastructure to target where outfalls are likely to be. And one way to go about doing this is to break your geographic area up into some quadrants that then you, you visit them one at a time looking for those junctions. It's a way to help kind of focus your efforts from your entire area down to smaller, more targeted areas. Excuse me. This also gets tricky though, because a lot of times in GIS, when you're mapping and you're looking at what's actually discharging to a receiving water body, pipes don't actually touch stream lines in GIS, and sometimes they're actually quite a distance away. So what this graphic is showing here are some examples of, in the blue we've got known outfalls that were mapped, and then in the orange we have some possible outfalls. And in order to determine what is and isn't an outfall, we looked at this criteria of, based on pipe diameter, proximity to stream, and slope, how likely is it that the water would actually make it to the receiving water. So one way to kind of deal with that issue of what is close and what isn't. And then another issue is that system connectivity can be a problem. So if your pipes don't actually touch in GIS, do you make a professional judgment call that yes, there's probably surface flow that connects those, or do you try to maintain broad rules for consistency? And so that's always a challenge. Once you have people starting to make judgment calls, the consistency becomes an issue. So for discharge points, primarily when we've done mapping, we've been, one of the examples that we focus on for discharge points are infiltration facilities, and that's what's being shown in this drawing. We also look at perforated pipes, and then there's a question there of where do you put your point. In many of the projects we've worked on, we put the point at the beginning of the perforated pipe when it leaves the stormwater system. Some things that are a little ambiguous with this: what do you do if you have stream flow in pipes? And what is a natural versus a man-made channel? So my point with these two slides is that it's very possible to do this mapping in a GIS environment. There are just a lot of considerations that need to be taken into account. But by thinking about a framework up front, you can do a lot of the legwork of figuring out, approximately what's in the field. And then again, there's this issue of the segmentation of pipes and ditches. So what do you actually consider as being connected? So the requirement of mapping receiving waters is probably one of the most straightforward. I'm not going to say much about this other than that there is geographic data available from numerous agencies for this. And if you don't have a watercourse layer already, it's possible to create that from LiDAR data. And this is another one that is not so much a GIS mapping exercise, but for thoroughness, we wanted to mention this requirement of mapping BMPs that are owned and maintained by the permittees. So in this case, this is primarily something that can be mapped through, coordination with the folks doing field inspections, using field data collection tools, and I'll talk about that more later. So this section on the tributary conveyance mapping, so this is tributary conveyances to all known outfalls and discharge points with a 24-inch nominal diameter or larger. Again, for phase 1, that's an 8-inch. So this is the big one, and this is basically saying you have to map your system. And a lot of times what this ends up looking like is CAD data. So you end up having huge amounts of as-built drawings that come in all kinds of formats. So I want to talk a little bit about some of the considerations when digitizing data from CAD drawings. The first one is it's really time consuming. Anybody who has had to georeference and digitize data from hard copy maps knows it takes a lot of time. And because it takes a lot of time, it's really tempting to figure out the fastest, cheapest way possible to get it done. However, there is a lot of benefit in having folks who have stormwater expertise being involved with digitizing this infrastructure. It's sort of having a set of eyes on this stuff who really understand what they're looking at results in better quality data. So potentially a little more cost up front, but better data in the long run. A consideration here is, when you're georeferencing, the world is changing. So if you have older CAD drawings, the facilities may not be on the ground anymore. The aerial may be dramatically different. So it can be challenging to figure out where that fits in the world. So one of the data sets that is most helpful for georeferencing this stuff is parcel boundaries, because they tend to change less frequently than some of the other data sets that you might use. And I want to just mention folks think, well, can't I just bring all of these CAD drawings that I'm getting and use that in GIS? And that's challenging because of, there's a sort of mixed level of quality with that. So that data may come not in a coordinate system, maybe inconsistently formatted, maybe in geometry types that are not compatible with GIS. So one way around this would be to work with your planning departments to develop criteria for submittals of CAD data that make it so that it's designed to be imported directly into your GIS, which is a good idea for long-term maintenance of your data. This is constantly changing. And topology is really, really important. So making sure that things are actually connected. Sometimes they look like they're connected until you zoom way in and they're not. And the topology is important for being able to make the most of your data. So for things like modeling or routing, knowing where things are flowing, paying attention to topology is key. And this is just a quick graphic showing what we see a lot with CAD data. So this is an example drawing when we worked with City of Sammamish, where the hard copy drawing had some of these invert elevations drawn out or crossed out, new ones written in. The CAD data didn't get updated with that information though, so if you were to just use the CAD data, you'd be missing what actually happened in the as-built. One other thing on tributary conveyances, so some considerations for mapping your non-piped systems. And there are some resources available on the King County website for this. They have some fact sheets on mapping and ditch prioritization. So if you don't have any ditches at all, we've developed some fact sheets with the county on how to get started with that. So some techniques for that. And then we also worked with the county to develop a toolkit that helps to streamline field data collection for ditches and a desktop toolbox for ditch prioritization. And I'm not going to talk a ton about this because Rebecca Dugapolsky is doing a presentation later today with King County on this larger project. Another consideration with tributary conveyances, so there is a requirement to map the associated drainage area for outfalls and discharge points of 24 or 8 inches nominal diameter. Delineating basins in urban versus rural areas is really different. So in rural areas, you may be able to just take LiDAR, run an analysis that looks at surface flow, and you're good to go. However, in urban areas, you have the pipe network to deal with. So there's some strategies for incorporating piped conveyances into your LiDAR data. So one technique is to take your pipe network, essentially burn it in to your DEM by dropping the elevation along those pipes, forcing the DEM to recognize them as streams. Then when you place your pour points for delineating basins, you're taking into account both your natural conveyance and your piped conveyances. And this can speed up the process significantly. So if you're doing this by hand, which a lot of people do when you're dealing with stormwater data, you can get accurate mapping pretty quickly by going that route, assuming you have good conveyance data to begin with. So this section is talking about the requirement to map connections to the MS4, so between facilities owned and operated by the permittee and the MS4. So some of the considerations for this type of mapping is just knowing where your system connects. It's not always as straightforward as it seems. And more importantly, knowing where it discharges. So if your facility connects to a system that then discharges 3 miles away into the sound, what does that look like for tracing the path to get there? And that's an important question because if your facility discharges to a location that has a 24-inch outfall or greater, then the basin delineation is required. And it gets tricky when you're crossing jurisdictional boundaries there. So if you own a facility that connects to the MS4 that then discharges in a different jurisdiction, who's responsible for doing that mapping? And desktop tracing of the routes for this can be really, really helpful, confirmed with field verification. So this is just a graphic kind of illustrating, we've got on the left here a facility maintained by Seattle. It leaves the property and then connects, but then is that where they have to stop mapping, or do they trace it all the way to the outfall as shown on the right? So ultimately that's what we did. We just helped support them in delineating the basin that their facility was in, but if in other cases, it becomes a sticky question of who's actually responsible for the mapping. So there's also a requirement for delineating areas that don't discharge to surface water, and I'm not going to spend a lot of time talking about this one, other than to say that this is generally a process of elimination, right? When you figure out what does discharge, what you're left with is what doesn't. So that's generally been our approach is, first looking at what does discharge and then kind of using that process of elimination. So some mapping resources. There are geodatabase frameworks the Washington Stormwater Center has a stormwater infrastructure framework that can be used as a good starting point for doing this mapping. Esri also has a local government model that has a stormwater utility network. So either of these can be downloaded as templates that will give you a place to start for what attributes you would need to record. There's also a lot of open data sources for finding some of the supporting information. So this includes, for example, ecology has hydrography, watershed boundaries, jurisdiction boundaries. There's Washington State Department of Transportation, and then other county and city resources. For some reference materials on interpreting this stuff, there are the Ecology GIS mapping standards. Again, there's this ditch maintenance and enhancement toolkit that Rebecca will talk about in her session, which is a great set of tools for just getting started with ditch mapping. And then a plug for using field technology. So tools like Esri's Collector app and Survey 123 really help with being able to go out and collect robust field data. So briefly, what do you do all of this mapping, how can you actually put it to work? So touching briefly on the GIS side of the ditch maintenance project for King County. So what this looks like is you've matched your ditches, you've mapped your ditches, and now you look at infrastructure significance. Then you can go out and assess condition and use a toolbox in GIS combining that information for prioritization. So this is another one where we use cloud-based mapping. So very briefly, to talk about where we're headed. So in the 2019-2024 permit cycle, this is draft at this point. Everything here is on the Municipal Stormwater Permit Fact Sheet, this section 6.5.24. A major theme in this is bringing statewide consistency to the mapping requirements. There's been some reformatting for clarity. And there's a new requirement for all known outfalls that you're required to collect and report size and material at a minimum as that information becomes available. So survey is not required, but moving forward, you need to collect that. Proposed new feature is mapping all known connections from the MS4 to privately owned stormwater systems. For phase ones, you'll now need to map 50% of areas not previously mapped for tributary conveyances, so it's outside of that urban or higher density rural areas that applied last time. The electronic format is now required, it's no longer recommended. In Western Washington, there's clarification for ongoing mapping requirements and a push to become more consistent with the phase one permit structure, so both in language and requirements. And in Eastern Washington, the goal is to make the phase two requirements more consistent and also requiring known discharge points and known and new MS4 connections to be mapped. And finally, as a last, I wanted to mention the stormwater management action planning that's in the draft version of the permit. There's draft guidance document on this. It's a requirement for comprehensive long-range watershed planning. Pretty big requirement, so the guidance document for that is a good resource. And GIS mapping and planning tools will be great resources for meeting that requirement. And then just want to mention that a lot of jurisdictions are moving towards this trend of incorporating social equity into, so equity and social justice into capital project prioritization. So another example of, how do you use this data once you've developed it? And again, leverage the electronic platforms that allow you to collect data and be consistent. And that's it.